Hello and welcome to this third module of our course. And in this module, we're going to talk about predictive methods using econometrics and data science in general. I'm going to show you what is to perform a prediction using data. We're going to talk about the difference between causal inference and prediction. I'm going to talk a bit about understanding the objectives of prediction in econometrics, and I'm going to show some of the models that are more used in predicting data, predicting variables. In the last part of this class, we're going to talk about how to use artificial intelligence, specifically the LLM models, to perform our analysis, and it's great. You'll see at the end of the class. So let's start with talking about what's predictive modeling, why it matters. The idea of predictive modeling is to use historical data and the methods we're going to talk about here, the methodologies to forecast the future outcomes of a certain variable or even identify an unknown variable. And the core goal is to build models that accurately estimate future behavior or patterns based on observed relationships. And it can be applied in economics and finance, forecasting, as it says here, GDP, inflation, stock prices, consumer demand, credit risk, and all kinds of series with a certain number. If you have a series of time with a certain number attributed to that time, you probably will be able to build some kind of model to predict that variable, unless it's a completely random variable. Then we have like a white noise that can't be predicted. But most of the times, if we're talking about macroeconomic data, sales, anything that you can measure in a regular way, most of the times we can apply at least one of the methodologies available to try to predict the next value. And I believe it's clear that if we can predict the price of a stock, for example, accurately, we can make money out of it. If we can predict the consumption, the electricity consumption of a certain region, we can make money out of it. And many other things that if we predict properly, we can solve all our problems or make money. Both things are important. Let me show you a practical example in public policy of using predictive models. So let's think that, let's suppose that I'm trying to predict high school dropouts, the risk of a certain student drop out of high school. I know that for most developed countries, that's not really a problem, an issue, but that's still a big problem in underdeveloped countries. And the objective of this would be to help education departments identify students at risk of dropping out of school, so implement policies to help them. So that's the idea. If you have the profile of students that drop out of school, you can identify why that's happening and try to produce policies to try to avoid that from happening. Before we enter the specifics of this, we have to make a clear distinction between prediction and causal inference, because sometimes you try to understand the measure in which one variable affects the other, or more than that, if one variable is the cause, is the reason why another variable has some sort of variation. If we focus on discovering the cause, it's a causal inference type of analysis. If we just want to see, to predict the variable, if our effort is to predict the value of the variable without really understanding the logic behind it, then we go to prediction. So when we talk about causal inference, the fundamental question is, what is the impact of X on Y, of variable X on variable Y? And we're concerned about the bias and consistency of the estimators. That's one thing. If we're focusing on prediction, then we think more about forecasting the value. And we don't worry that much about the reason behind it. We're worried about getting a precise model. So the fundamental question would be, what will be the value of Y given X? We're concerned with prediction accuracy. And the difference is, the obvious differences are that causality requires stronger assumptions. The variables must be exogenous. Prediction can use correlational relationships without implying causality, and evaluation metrics are different for both purposes. We can use different methodologies and we can reach different conclusions. If, for example, if we have a predictive model that works really well, it doesn't really matter what's the rationale behind it, because if the model works and we get to predict it well, that's fine. On the other hand, if we're looking at a public policy, for example, we want to identify if a certain public policy has an influence on a variable that we're interested in, like poverty, access to school, things like that. We have to identify if the public money being spent on one specific use is actually making an impact on what we want to do. It's harder to identify because you have to rule out alternative explanations and hypotheses, but it's also important, especially if we're dealing with government intervention, public policies, things that require a clear identification of the cause. So when we're trying to predict something, how do we start? What is the first step? The first thing I would recommend is data exploration. The idea is to understand the data sets, try to get different series of data, the distributions, and try to find relations that can be modeled. That is, find variables that are influenced by other variables and not completely unrelated. That's the basic behavior of data predictive modeling. You can use it, and it makes sense to use charts, histograms, scatter plots, box plots, heat maps. Try to identify direct trends, seasonality. When you have like sales, for example, if you look for ice cream sales, you're probably going to sell more during summer and less during winter, and that's going to have a seasonal behavior. You have to identify those things in order to predict a certain value that you want. And correlations analysis, you can get different variables, see if they are correlated somehow, see if they have a common cause for both of them to behave in a certain way, or if one seems to cause the other. You come up with a hypothesis. That's the idea. You start as any scientific method exploration. You're going to start to try to find relations, try to find things that seem to be connected, to formulate a hypothesis, and then you test that hypothesis with the models that we're working in this course. What are the main models for predicting variables or predicting models in general? I'm going to talk about some of those we have already studied in our previous classes, and some we will study in the future, in our future classes. But in this case, for example, we're talking about the high school dropout risk, the example of our previous slide. In this specific example, the logistic or probit regression is a very good methodology. It works with binary outcome models. We can use that to, you have a dependent variable, in this case, the binary variable as in dropout yes or dropout no, 0 or 1. And we estimate the probability of a dropout based on the characteristics that we can observe in probability. That makes sense. It's a good baseline for prediction, but this methodology is more adequate for a binary prediction. If we use other types of data, we might need other methodologies. For example, number 2 here, panel data models, fixed or random effects. We've talked about them on module 2, in which I presented the methodology, how it works, how the data is structured, and in the same logic that we use to understand the relations, we can use to predict models as well. The same idea of building a fixed or random effects, running the tests, identifying the same tests to identify if the model is proper, if the methodology is proper for the data. We get the coefficients, and we can try to use those coefficients to test for predicting the next value. That's also something that we use. I put here a little short example in our dropout example. The dropout could be a dependent variable that depends on those other variables here. This is the basic form of the fixed effects model. There's the time fixed effects variable here in the equation. which you can build using the softwares that we presented in our previous class. And the propensity score matching model is also useful for stimulating randomized experiments by matching treated and untreated students, in this case, the example we're talking about, with similar characteristics. It's useful for evaluating the effect of programs when randomized controlled treatments are not feasible. In real life, it's not always that we can get a bunch of people, like a random group of people, treat some of them and not others, and get them all together under the exact same circumstances to see if our treatment makes a difference. That's simply not possible to do in real life in most situations. So we try to get as close as possible to this, and the propensity score matching is one of those methodologies. And the type of model that were very popular before the growth, this huge growth on artificial intelligence, was the machine learning methods. The name machine learning makes us think of something that AI does today. The idea that you're just going to put data in some software, that software is going to learn somehow, and you're going to ask him or program the software to do something and bring you answers. That's what we do in AI. That's not what machine learning does when we're talking about predictive modeling or econometrics and data analysis in general. It's called machine learning because in some cases, like this neural network and some other cases, you can present a certain database and present the data that you want to discover, and the method is going to try to match the information and try to classify what you're presenting as new information according to what the previous information that the model had. So it worked in the past. It's still a good methodology. It's still useful. And we're going to talk a bit about these methodologies, but they're quite complicated, very hard to build. The analysis, the math, and all the programming behind it tends to be complicated. So we're going to talk more about AI, which is already the evolution of these methodologies. And that's what I'm going to show you at the end of this video. But before that, let me just go through the main differences between machine learning methods and econometrics. So the main differences between machine learning and econometrics, the methods, is that in machine learning, the main purpose is to make a good prediction. In econometrics, we try to discover the influences between variables, understand the causal relations and the amount that a certain variable affects another variable. The focus of machine learning is accuracy. It's trying to get a precise model. In econometrics, we try to identify the reasons behind the variations between variables. Machine learning models usually require large data sets. And in econometrics, depending on the type of analysis, you can use smaller data sets. If we talk about macroeconomic data of countries, for example, GDP growth, it doesn't make much sense use very, very long time series, like hundreds of years. Countries change much. It's hard to say that something that happened 50 years ago will make a difference on something happening today in a country in terms of macroeconomic variation. Machine learning methods tend to work with larger data sets of higher frequency. And in econometrics, we tend to work with a much longer frequency, especially when we talk about countries or large companies, sales. The data is usually annual, sometimes semestral. And for machine learning, for example, if we're talking about the stock price, the price of a certain stock, the price will change maybe every second. So those different methods work for different types of data. And machine learning is more flexible. It's not nonlinear. It's got many features, many characteristics that the model uses to define, to produce this prediction. In econometrics, you have to perform lots of tests, watch residuals, for example, see if the variable is stationary, all those things for the model to be considered valid. And in machine learning, the model doesn't care about this. It just worries about producing a good prediction. And in machine learning, because of that, the interpretability is very low. You don't get to interpret what the machine learning method did. Methodologies in econometrics tend to focus on understanding the logic behind the variations that we're studying. And to end this class, I would like to present you some of the prompts that I've been testing to make your life easier if you're trying to write a paper or produce some article, that if you have data that you need to analyze, if you need to work on your thesis or something like that. I would like to present you some of the ideas that I had while working with the large LLM models and how they solve lots of problems, how they make our lives much easier. So the first thing I wrote is, give me a list of prompts that I can use to explore real data and situations to perform predictive analysis using econometric methods. I typed this into Google Gemini. Check this out. So this is what I wrote. Give me the list of prompts that I can use and real life data. And it comes up with this. So finance and economics, predicting loan default risk, forecasting stock market, predicting GDP growth, business and marketing, predicting customer churn, forecasting product sales, public policy, predicting student dropout rates, predicting crime hotspots. And if you keep asking, it's going to keep on giving you lots of examples in which you can use real data. And then it comes up with the real data. Usually it gives suggestions, but in certain cases, for example, this macroeconomic data, it says Yahoo Finance, you can use the Fed. I checked some of the sources, and the ones that were open source that we could use were the ones that worked best for our case, were the ones from the Federal Reserve Economic Data and World Bank. I typed those. And then I went to our second prompt, which is, what is the predicted quarterly GDP growth rate for a country? Well, that's the prompt it had. And then following Gemini's own suggestion, I wrote this prompt: use macroeconomic data from sources like the Federal Reserve Economic Data, World Bank, or national statistical agencies to build a VAR model to predict the GDP growth of the United States in 2026. VAR is one autoregressive methodology using also other variates other than the variate itself. And Gemini gave me the step-by-step how to do it. Then select your variable, gather, prepare the data, specify the VAR model, generate the forecast, and then I ask, can you do it? It gave me the step-by-step, so can you do it? And it says, no, I can't. I tried the same thing using Chat GPT. I'm not a subscriber, but it gave me the step-by-step, selecting the variable, getting the data. It gave me Python commands, how to do it using Python, fit the model and all that. If you ask R, it gives you R and gives you the database. And I tried ask him to do it for me, and then it says that it couldn't use the package, and because I don't pay, I believe it doesn't work really well. So, but Claude did incredibly well. This is the free version, it's not even the paid version. And I wrote the same thing: use macroeconomic data from sources like the Fed to try to estimate, use a VAR model to predict the GDP growth. And then it did everything. It comes up, it presents you the data sources, the type of model that they build, the VAR restrictions, the VAC model, and then the forecasts for 4 quarters, 8 quarters. You can type, and then it gives you the model. This is the data, the raw data, historical versus predicted. The predicted is this part here. You see this little dotted line is the predicted. It gives us the coefficients of the model. So it says GDP. Well, it's a vector autoregressive. So the autoregressive part presents here the p-value really small, so this coefficient is relevant. This GDP 2 times 2 legs, not that much. It says here for 1%, 5%, or 10%. It would be relevant for less than 10%. Unemployment, also relevant. Investment, apparently not relevant. And it's impressive how it even interprets the coefficients. So it says here, GDP, 1 leg, strong persistence effect. GDP, 2 legs, secondary leg effect, marginally significant. A total AR effect, 80%. indicates strong momentum in GDP growth. That means that the previous period is very important to explain the next period. And then the other variables it used: unemployment, inflation, Fed funds rate, consumer spending, investment, in the constant term, and says which ones are relevant, which ones are not, and the interpretation of the model. This is great. This is great. If you're presenting this as a formal paper, like your PhD thesis, obviously you're not going to use it this way. But if you're trying to find things that make sense among all the data available, this is great. Because if you're trying to model the GDP growth of the United States with whatever methodology, you can use this prompt to realize which variables are relevant, because it presents you so GDP, unemployment, inflation, interest rates, those things are relevant. So as it presents it to you this way, without having to know any econometrics at all, this is amazing. So as far as I could discover, Claude seems to be the best LLM model to perform econometric analysis. I haven't done much because I don't have the paid version of Claude. I only pay for Google Gemini, and Google Gemini is honest to say that it doesn't run this type of analysis, and Claude does it even in the free version. So before entering the world of econometric softwares, if you're about to write a paper, you can enter Claude, apparently the best one that we have, subscribe it, and get data. Try to ask him to get the original sources of data as the Fed, World Bank, because the model goes to the website, downloads the data, and does the first analysis that you need to then formulate your hypothesis. And obviously, you can also use the LLM model to formulate hypothesis. Check this out. Let's see this prompt. I just wrote this prompt to see what it brings us. But formulate 3 hypotheses that can be tested using predictive models to explain the relationship between US GDP growth and macroeconomic variables, so I can write a thesis about the future of the US economy. And there you go. The Phillips curve breakdown hypothesis, the monetary policy transmission mechanism, and the consumption investment rebalancing hypothesis. And it says test for structural breaks. If you keep on asking, it's going to present you the methodology, or look, time varying parameter models, regime switching, thesis, structure suggestion, things that you can do. So if you're struggling to write a paper, write an article, or analyze data that you already have, I strongly recommend that you can use those LLM models, especially Claude in this case, and ask for ideas and ask him to do the calculations, even before you start doing it yourself. Naturally, this model won't be as good as the softwares that do this, because those models were not built to perform econometric analysis. But when you are exploring possibilities to formulate a hypothesis and define a methodology and how you can get the data and how you can apply the data and alternative tests and robustness tests, the artificial intelligence will help you a lot. And this is the examples I wanted to show you before we move on to our next subjects. So thank you for watching, and I hope you have enjoyed this video as much as I have when I discovered that LLM models were solving those huge problems for us. Thank you, and see you next class.